Hi everyone, this video is not a tutorial, it is what I call the raw format. I will do almost zero editing on it, and it's about making an acoustic simulation from scratch. I hope this helps and completes the tutorials. Okay, so we are going to make the simulation, the LEM acoustic simulation of the B2 cabinet from the DNB brand. So this cabinet is an hybrid bandpass horn. So let me tell you why. First, hybrid because the speakers that are on each side of these panels play on one side in a horn and on the other side with in a chamber that has bass reflex, so it's hybrid. And then the bandpass horn, because the horn size, like the horn area, goes smaller and then bigger again. So this is what makes a bandpass horn. This is going to be made in Akabak with the LEM simulations. On my website there is currently a horn resp simulation, but since Akabak tends to plot more details, I wanted to make it with Akabak and update the simulation on the website. Fair enough. Let's get started. So what I will do first, well, is hide this since I don't need it, and create a sketch with a view from above, where I will just get all the physical dimensions that I will need to input in Akabak in order to make the simulation. So the two speakers are facing, like the front side of the speakers are facing the horn, so it's something like this. Alright, and I just want to get all the physical dimensions right now, so then when I am in Akabak, I can just input all the values and get the thing running. Okay, so let's go. Well, first, since it is an hybrid cabinet, there's a horn and a bass reflex chamber, so I will need the volume of the rear chamber. So let me just get the area in 2D, without the bass reflex port, of course. And the area is this value right here. Alright, I will just need to write it down, but in the form of volume. So currently, let me take this. This is the value here. 565 7 times. So this is currently like the area of the base, and if I take the inner width, inner height of the cabinet, and that I multiply it here, I will get the volume in millimeters cube. This is it. And what I want to do for the cabinet is convert it into liters. So right now, millimeters cube to centimeters cube would be to remove 3, so this would be this value. And once again, to switch to decimeters cube, this is the volume that the chamber has. So let me write it down. 9, and yeah, let's round it a bit. It's fine. Then I need to know the distance from the speaker to the bass reflex port. So this is approximative. I don't need to plot a very exact value, which is approximately this. Let me get some names for that. Okay. What I also need to know is the length of the bass reflex port. So right now, this is this long. So let me write down. And also the area. So the area of the port is its opening. So this length that I will write down. Oh, hold on, no, I need to calculate it. Since it's the area, it's 70 times the 8, the inner 8, which is this value. In centimeters, it's you switch to, it's 380. Let me get all the units so it's not confusing. Maybe I just should switch all to centimeters and liters. This would be maybe more handy and less confusing. All right. So this is currently all the values that I need for the rear part of the cabinet. Now let's focus on the horn. So right now, the shape of the horn makes me want to create an offset horn in Akabak, which will be like the first area will be from here to here and is like before the speaker. Then there's after the speaker going to the outside. And finally, the next change in the horn shape is this one. So I have all the areas, all the width, and then multiplied by the height, I will have the area. And the length of each segment will be this one. Right. Right. This currently is what I need. So let me write down the values. Centimeters. Okay. So we get the width and we need the length between each segment. So I will input it like this just for my notes, but you really have you just can do it the way you want. So it's 23.8. Here it's 23.5. Here 41.1. All right. Yeah, that's all we have to do. Let me think about it. We need the overall dimensions of the cabinet. So we can just validate that and yeah, let's keep it. So this is like the depth, this is the width, and this is the height. All right. What else do I need? I do need to know the distance between the center of the cabinet and the port output, which is this value. This also is all in centimeters. And well, I think we're good to go for now. Oh no, hold on. Hold on. We do have a volume of air ahead, like before, like the speaker is mounted on this side of the plank. So there is a little volume of air before the horn. So this does not have a big impact on the response, but I do want to make it accurate. So we need to know the value here. So this would be a duct. Um, and let me just put it before the horn. This is the throat. Length would be length would be the thickness of wood, yeah, 1.8. And since I use duct, I need to know the area. Area is I have it around here, I think. Yeah. Area is in centimeters squared. And 9. Oh, sorry. Okay. Yep, this is it. Okay, so we've got everything running, ready. And I think it's time to go to Akabak. Let me think about it. But yeah, I think we've got everything. So let's go. So open Akabak and start to input everything you need to know. Everything the software needs to know, in fact. So I will oh, alright, yeah, if you double click here, it opens the component window too. This is something handy to know. So we need a source, GND, to power the two speakers, of course. Then, well, let's wipe out the two speakers. The speakers will be powered in parallel, which make them connect like that. Okay, and then this is the front side of the two cabinet, which will be the same horn. And this is the rear side, which will have independent rear chamber and bus reflex ports. So let's start with this. Enclosure vented is the chamber with a bus reflex port. They both have the same, so I will just fill this one and then copy paste it to here. And then for the horn, we've said this was a waveguide, first in offset, then a second one, and then a third one, which corresponds to the first one here, second one, and third one. Okay. Just want to make sure this is clear for everyone. So I connect the two sides to. Oh, hold on. Well, no. See, I'm wrong. This is not how disconnect. Since the speakers connect between the first and second horn, we have to make a little offset in the software. So like this, we say that the speaker connects between the first and the second one. Okay. And finally, radiator, because the horn plays to the outside of the cabinet. And this is almost done. Okay. Let's fill in the informations. We have, for this one, we have the volume to input. Oh, sorry. The length, the length is between the port and the speaker, which is this value. And then the vent temperature, so select the area. And port area is 380. Okay, there's only one port. Oh no, this is the port length. Oh, sorry. Yeah, mixed it up. Port length 26.8. And it calculates automatically the resonant frequency of the bass reflex. This is nice. ETAB, ETAV, leave that empty. Lamped element, of course. I would tend to say that since the the speaker plays to the bass reflex board almost like after having the waves travel the whole chamber. Well, no, hold on. Now the waves can either go through the bass reflex board or to the chamber in every direction, so the two are in parallel. If the waves had to go through the chamber first, the entire chamber, and then the bass reflex board, it would be a serial. But right now, no, it's not. It's not serial. It's parallel. So here I input the first value I wanted to put here, 35.5. This is the distance between the speaker and the port, okay? And then ref to pieces will have to be input later, but this is filled, so I can copy paste it, Control C, Control V, right? And this is good. Then for the horns, I'm going to input a rectangle. The height of the cabinet is always the same. It's 54.4. Maybe I can set that first. Oh well. Okay, so the first width is this value. Copy paste in 54.4. Okay, and the output is this value with the tree, please. This is a square, 4, and the length between the two is what I've noted here. Okay, the, the slope is conical. Let's go to the second one. This is the third value. Oh no, hold on, I did it wrong. And this is, alright, this is 29. And the length between the second one and the third one is this value. Once again, conical, alright. And last one is this value. To the output, which is the same as the height in the cabinet. Okay, and the distance between the two is 41.1. I can put conical and then go in here and say that this is lumped element. The element right before is the waveguide number 3, and the ref to pieces will be set later. What do we have left is the throat. I haven't input the throat. So first, before I'm gonna just modify a bit this, input duct. Since they both have the same, I will just put the first one and copy paste. Right here. In the throat, the square area was this value, and the length was the thickness of wood. You can select, you can leave the rest like this, it's fine. And then copy paste it, put it right here, right between the front output of the speaker and the horn. So it corresponds here, right between the front output of the speaker, which is about here, and the horn, which is here. So this is really represent in the 3D model this space right here, okay? Okay, just have to connect it. And, well, this is done. Easy, right? We just have to set the values of the component. So, the value of the speaker. The original plan, let's do it like this, recommended this speaker, so we're gonna have to search for it. G41. Well, let's take this website. It's got nice and clean values. And we can go back to the software. Let me put it here. And input the values. All right, square area is this value. Diaphront and diaphragm are the same. MMS is 182. VAS, this value, all right. QMS 7.6. RE is 4.8. QES 0.3. And VC LE is 1.8. All right. So since the two speakers are the same, I'm just gonna delete the second one, copy paste the first one, and put it in place of the second one I had. Okay. And the LEM part is almost ready. The only missing thing is the Ref2P source for both the radiator and the vented enclosures. So let's switch to BEM and create some nodes and cabinets so we can link the LEM to a 3D environment. I will create, well, first let's create a subdomain exterior to tell that this is for the 3D environment outside of the cabinet, and have a pressure box, right? Since the oh, hold on. Since it has three outputs: bass reflex port, horn, bass reflex port. I want to make a pressure box of the whole cabinet and three pressure points for the output. Or even what I could do, in fact, is have a pressure box and a radiating area of this pressure box, be that like the horn, and add two pressure points for the bass reflex on each side. I think this is the best to do here. So, direction on the Z axis. Okay. And then visual will be the dimensions of the box, which is this 58, 92. Click apply. Right. This is not to scale currently. See, this is like cut on the edge because Akabak doesn't have any physical dimensions yet, but it will appear soon enough. Then directivity is where is said to be the horn output. So as we have measured it, 54.4, 54.4. Okay, and see, now we have dimensions, it's scaled down, and it's almost ready to go. The only thing we have left to do is the nodes of the bass reflex ports. So I create the nodes. The first one, and this is why I measured the distance between the port and the horn, because like the distance between the center of the horn and the center of the port, because this is how I will position it. Initially the point will be at 0, and if I offset on the x-axis negatively of this value, the point will be centered on the port. So we have the first one negative 37 here, and the other one positive 37 here. If I click apply, they don't show up because I have to check the box, and here they are. Okay. Next thing, we go back to BEM and create pressure points. The first one will be like bass reflex left with the point 1001, and second pressure point. See, by the way, this one turned red. Okay, so this is like because we use it with the pressure points. And so the second one will be bass reflex right and linked to the 1002 point. And see, this one will turn red when I click apply. All right. Maybe this is clearer if I uncheck this. because the black displays behind the red, so it's not very clear, but it's alright. And finally, we want a third point that will be 1 meter in front of the cabinet, so in centimeters it's 100. Click apply, it's okay. And now, if I check it, we can see that the measurement of the microphone will be done here. Alright, back to the LEM. Ref to P source is bass reflex left for this one. This one got the bass reflex right. In here we can set the pressure box. Okay, and this is almost ready to run. I have to go into the frequencies first. Tell that I want the simulations from 10 to 20k and go with 80, for example. Yeah, I think this is a good value. Click OK. Set the level of driving. So since I have two speakers in parallel, this is 4 ohms impedance. Because the drivers are 8 ohm normal impedance, RE is 4.8, so the nominal impedance, is always above this value. It's close to 4, so you could think it's 4, but no, actually it's 8. And if it was 4, the RE value would be below 4, like 3 or 2.8 or something like this. So, 2 8 ohms nominal impedance speakers in parallel make 4 ohms, and 1 watt, as we've seen in the tutorial, make a driving of 2 volts. RMS, validate. So this, of course, opened VAX, but we don't care yet. We can go in observation, create a measurement of the radiation at a specific point, and link it to the P1003. And see if I go here, there's gonna be a gray point that appears, which is my virtual microphone, right there. Great. Now the range, I usually tend to say that 70 to 120 is good. So you cannot specify the 3 values. If I click apply, it say I have over specified because 70 plus 50 equals 120. So I either input these two or these two, or even this one and this one, whatever, but only 2 out of the 3. I want to see level dB plus phase, for example. Click apply, close, and we can directly, first save it. So this is DNB B2. Save and calculate. And if I go back to VAX, I've got my response. The range did not took effect, so I'm gonna put it back. And see, it's great. We've already got the simulation, and it's only been like half, maybe 25 minutes. So quite well. Alright, and then so let me show you some more since we are making this video. Let's see some more stuff. For the website, I go export as picture. 167. Why this value? This is very specific, yes, because this is the resolution of the on-resp export. So I just stick to it because in the first time the website was with on-resp simulations, and when I switched to Akabak, I thought, well, let's keep the same picture size. So this is fine like this. Okay, so I click that like that, and copy the pictures and put it on my website. And this is done. Well, I also save the simulation result with the same name, and we are set. So thanks for watching.